Good morning friends. Today we are going to learn the construction of the radiographic films. Okay, we will learn word by word. We will understand. Okay, radiographic films consist of a transparent, flexible base of clear cellulose derivative. Okay, what they are telling? This is the base material, clear cellulose derivative, or like material like that. One or both sides of this base is coated with light sensitive emulsion. You see, emulsion, it's a mixture, means a mixture of silver halide suspended in gelatin. Okay, what they said, base is clear cellulose derivative, right? Cellulose derivative, and they have emulsion. What emulsion contains? Silver halide suspended in gelatin. Okay, the silver halides is distributed throughout the emulsion as minute crystals. Okay, and exposure to radiation such as X-rays, gamma rays, or visible light changes its physical structure. Okay, this change is of such a nature that it cannot be detected by ordinary physical methods. Okay, this emulsion contains silver halide suspended in gelatin. Okay, whenever it is exposed to X-rays or gamma rays, plus X-rays, gamma rays, then its physical structure changes. Which physical structure? The silver halide physical structure. Physical structure changes. Okay, so the physical structure changes the physical structure. This change is of such a nature that it cannot be detected by ordinary physical methods. That means while seeing you cannot see any change in the film. Okay, and is called latent image since cannot be seen, so it is called latent image. Okay, however, when the exposed film is treated with a chemical solution called developer, okay, film plus developer, it contains what? Latent image. Latent image. The reaction takes place causing the formation of a tiny granules of black metallic silver. So reaction takes place and forms black metallic silver. Tiny granules. Okay, it is this silver suspended in the gelatin on both sides of the base that constitutes the image. Okay, next, the supercoat. The supercoat is a thin layer of clear hardened gelatin. Okay, what is the purpose of this? Which protects the underlying emulsion from damage during normal handling. Okay, the emulsion is the most important layer of the film because it is sensitive to X-rays, gamma rays, light, heat, pressure, and some chemicals. See, in order to protect this emulsion, a supercoat is there. It is clear hardened gelatin, right? To protect this emulsion, we are using this supercoat. Okay, the emulsion consists of a large number of minute grains of silver bromide, silver halide, embedded in a supporting medium of gelatin about 0.025 mm thickness. We told, right, this emulsion, it is of 0.025 mm thick. Okay, it contains what? It contains silver halide plus gelatin. Okay, modern films usually contain a small amount of silver iodide with a bromide as this increases sensitivity. So silver halide, it contains Ag iodine plus AgBr, so that sensitivity increases. When radiation strikes the emulsion, a change takes place in the physical structure of the grains. We told you, right? Initially it contains silver crystals. Now radiation is exposed, the film is exposed to radiation. Then the physical structure of the grains will get changed. It is called latent image. This effect is called the latent image. It cannot be detected by any normal physical means. The subbing layer consists of a mixture of gelatin and binding material. So what it contains? Gelatin plus binding material. It ensures that a thin emulsion layer adheres firmly to the base during the stages of processing. This is to ensure that emulsion adheres to the base. Emulsion adheres to the base during the processing. This is particularly important in high temperature automatic processing techniques and processing under tropical conditions. The base is necessary because the sensitive emulsion is far too weak and flabby to be handled by itself and must be centered on some firm support. See, this subbing layer is to give the this base is to give the firm support to the emulsion. Okay, and why subbing layer? During the developing process time, in order not to remove the emulsion, get removed the emulsion, we use the subbing layer. The original supports were glass plates, but these were heavy and fragile and have been replaced by cellulose estates. The majority of radiographic film emulsions used today, initially they used to use glass. Initially this base is glass, but they removed since it's fragile. Okay, the majority of radiographic film emulsions used today are coated on cellulose triestate or polyester such as ester, which forms a tough, transparent but flexible base. You understand, right? Initially this is glass, but now they changed it to cellulose triacetate. Why? To get flexibility. Okay, please subscribe, guys.